Good afternoon, Year 8. Today we are going to continue our session about expressions, and we are going to discuss a different concept. Last time we discussed how to evaluate expressions. Today we will discuss how to collect like terms. Now we have here a group of examples that makes us understand how to collect like terms. Let's look at each one of them, one at a time, and check if we do understand the meaning or not. What do we mean by like terms? Now, when I say 3a and 2a, these terms are like terms. It's as if I am saying 3 apples and 2 apples, because a here is the same variable. So I'm multiplying 3 by a, and I'm multiplying 2 by a. This is the same variable. Accordingly, they are like terms. So I'm going to simply add 3a plus 2a is equal to 5a. Same when I have 7b and 4b. These are like terms because I have the same variable. 7b plus 4b is going to be equal to 11b. I think it won't be hard for you to know what is the answers of question 3 and question 4. For question number 5 here, instead of addition, we're subtracting. 6a minus 3a. Again, I have the same variable, so these are like terms. 6a minus 3a will give me 3a as a value. The question after that, I have 4m minus 5m plus 4m. Don't do it in one step. Take your time. 4m minus 5m is going to be negative 1m. Negative 1m plus 4m is going to give you a value of 3m. Same way you can solve questions 10, 11, and 12. Let's look at it together. In question 11, for example, we have 11r minus 7r, which is 4r. 4r plus 11r is going to give you an answer of 15r. I don't think it's hard at all. Now, so far, all we had were like terms. Like in each expression, we had 3 different terms, and all of them were alike because they had the same variable. What about in this question here? We have negative 5t plus 9, and there is no t here, there is no variable, plus t minus 12. Let's agree that negative 5t and t both are like terms because they have the same variable. Now the sign follows whatever comes after it. So don't look at this as if it's minus 5t. No, this is one term which is negative 5t. While this t here takes the sign before it, so it's positive t. So negative 5t and positive t or plus t is going to give you negative 4t. Then we add the numbers together. Again, each number takes the sign before it. So positive 9 plus negative 12 gives you an answer of negative 3. Let's look at this question here. Question 17. 2b and negative 2b is 0b, right? There is no b. 2b, then negative 2b is 0b, which is actually 0, so we don't need to write it. And 7 plus 3, again, each term takes the sign before it. So positive 7 and positive 3 makes a positive 10. 0b is equal to 0, no need to write it, so my answer is 10. Let's look at the question after that. We have 5q. 5q is positive plus 6q. So that makes 11q. Then I have positive 4 minus 4 or positive 4 and the negative 4, which is a 0. Again, I don't need to write the 0. So this is 11q. Last one, we have negative 7n and positive 20n. Negative 7 plus positive 20 will give you positive 13n. Negative 8 plus 16 will give you positive 8. Okay, so collecting like terms is very easy. All I need to do is to take all the variables of which have the same letter together and take all the numbers together. Now, where do I see questions like that? We can see them as an application on geometry, as we have. Now, here we are supposed to find the perimeter of each shape. I have two shapes. The first one is a quadrilateral, it has 4 sides, and the lengths of each side is given by the expressions we have. So I have 4 sides here. So for me to find the value of the perimeter, in this case, I'm going to do the following. The first side, we're going to choose where to start from. I can start from y here. So the first side is y plus, so I'm done with y. The second one is y plus 3. Third one is y plus 7, and of course I'm adding all of them together. And the last one is 2y. Why did I do a tick like that? So I don't forget any of the sides. Now these are 4 sides, they're not a big deal. However, when we go to bigger shapes, like with more sides, it's going to be a little harder. So now that I know that the value of P is equal to the sum of all these, let's collect like terms. I have y and another y and another y and 2y. Let's add them together. Y plus y is 2y plus another y is 3y. 3y plus 2y is 5y. Then we have numbers. We have 3 and 7. 3 plus 7 is equal to 10. So the perimeter of this shape can be represented by the expression 5y plus 10. What about the second shape here? Now I have the length of this side, which is a. This side, which is parallel to it, is a plus 7. Can that help me to find this missing part? Well, if this is a and this is a plus 7, this must be 7. And again, I have here 2a plus 3, this value here. If this is 2a plus 3, and this part here is 3, take care that this shape is not to scale. So if this is 2a plus 3, and this part here is 3, it means that the remaining part is going to be 2a. Now, this shape has 6 sides, and when I find its perimeter, I need to take all these sides into consideration. I'll start from here. I have a plus 3 plus 7 plus 2a plus a plus 7 plus 2a plus 3. Now I know I have all the sides. I'm going to start adding, combining like terms or collecting like terms. I have a and 2a, that makes 3, and another a makes 4. Take care, when you see a only, it means like 1a. So I have 1a and 2a, that makes 3a. Another 1a makes 4a. And another 2a makes 6a. So I have 6a, this is my first term. My second term is going to be positive 3, positive 7, that makes a 10. Another positive 7, that makes 17. And another 3, that makes 20. So my answer is 6a plus 20. Okay, so the expression 6a plus 20 represents the perimeter of the shape. So now you have seen how do we collect like terms. We have seen how we can use that in application of the shape. Before we end this video, I want you to understand one other thing. Now, if we say a square plus a. Now, a square is not the same as a. actually its value is different. Like if a is equal to 2, a squared will be equal to 4, while a here will be equal only to 2. So these are not the same. So these are not like terms. I can't collect these. If I want to add these, they cannot be simplified. My answer will stay the same. If we say AB plus BA, now these are actually the same because these are multiplied by each other and multiplication is commutative. Commutative means that AB and BA are the same. So I can write them both as AB, and in this case, AB plus another AB makes 2AB. If I say 3AB plus 2B, these are not the same because the 3 here is multiplied by two different variables, but 2 here is multiplied by one variable. So this cannot be simplified. It will stay as it is, 3AB plus 2B. Okay? Now, for us to have two terms and say that these two terms are the same, the numbers has to be multiplied by the same variable as we had in the slide before. I add 2A to 3A, I added 7B to 4B, we added 5Q to 6Q, but we could not add, as we saw in our last slide, I cannot add A squared to A. Although it's the same variable, they don't have the same power. I cannot add 3AB to 2B because 3 is multiplied by two different variables, while B2 is multiplied by only one variable. I hope you find this helpful, and thank you for watching.